Hello, good afternoon, student, and welcome back to our lecture series on CPU scheduling. Today we are talking on dispatcher and different type of scheduling algorithms. Okay, in previous lecture we saw um, schedulers, different type of schedulers. So we talk about the dispatcher. Dispatcher is actually responsible for loading the process selected by the short-term scheduler on the CPU. As I told you, most of the multiprogramming systems can use the short-term scheduler for the better performance of CPU utilization. Okay, so dispatcher module gives control of the CPU to process selected by short-term scheduler, which I already told you. Okay, so for in dispatcher, what are the terms involved? The terms are switching context, switching to user mode, jumping to proper location in the user program to restart the program. Okay, for that purpose context switching is most important. That context switching can be done by the dispatcher only. And for dispatching process from one state to the other state, the most important factor matter, that is dispatch latency time. This time is takes for the dispatcher to stop one process and start another running process. Less is the dispatcher time, better is the performance of the CPU. Okay, this is the most important role of dispatcher. So let's see CPU scheduling. Now from the last lecture series we are talking on the CPU scheduling. What is the purpose of CPU scheduling, why CPU scheduling is necessary, and what are the terms involved in a CPU scheduling. Then the most important term for CPU scheduling is a algorithm. Means if your operating system choose a better algorithm for the scheduling, then your operating system gives better performance for the CPU. Okay, well, how there are different number of CPU scheduling algorithms. Which algorithm is better for which operating system? We can decide it based on some criteria. So for CPU scheduling, there are 5 most important criteria like CPU utilization, throughput, turnaround time, waiting time, and response time. Whereas CPU utilization is nothing but the how many times CPU busy as possible. It means less time CPU should be ideal during the execution of the process. That is called as a CPU utilization. Throughput means in minimum time, how many number of processes compiled their execution, means per unit time. If it is minimum, then the performance of your CPU utilization is better. Next is turnaround time. Turnaround time is amount of time to execute the particular process. Waiting time. Waiting time is amount of time a process has been waiting in a ready queue. And last is a response time. It is a time to take or it is a time to takes from when the request was submitted until the first response is produced, not output. For that purpose, time sharing environment is most preferable for improve the response time of your CPU. Okay, based on these 5 criteria, we discuss different CPU scheduling algorithms. There are 4 number of basic CPU scheduling algorithms are available. First is first come first serve. Second is shortest job first or shortest remaining job first. Third is a priority algorithm, and fourth is a round robin algorithm. We will see one by one. And the first algorithm is first come first serve scheduling algorithm. By taking one example, I explain the process of first come first serve scheduling algorithm. As the name suggests, first come first serve means the job or the process which comes first in the CPU, it gets the preference to execute in a running state. Means the process is the when process enter in a ready state, that process gets a first priority to enter in a running state. Okay, for that purpose, scheduling type of scheduling is most important. Sorry, I forgot to tell you, there are two type of scheduling methods for CPU, that is preemptive scheduling and non-preemptive scheduling. Preemptive scheduling means when the process is in a state, at that time high priority process is enter, or high priority process wants to enter in a same state. At that time, because of preemption, low priority process exited from the from that particular state, and high priority process is enter in that state. That type of process execution is called as a preemptive process execution. And the second is non-preemptive process execution, or non-preemptive way scheduling. Non-preemptive means if your process is enter in a running state, at that time whatever the CPU burst time required for the process, that process complete its own work, and then that process releases the running state. It doesn't matter which priority of the next incoming process or not. Such type of process execution is called as a non-preemptive process execution. Our first algorithm, first come first serve algorithm, based on non-preemptive process execution. Okay, let's see one example. That example contain three number of processes, P1, P2 and P3. Every process has its own burst time. That process P1 has its burst time 24 millisecond, process P2 has its burst time 3 millisecond, and process P3 has its burst time 3 milliseconds. Let's see how the process is executed by using first come first serve algorithm. In first come first serve algorithm, first of all, for solving this problem, we have to construct one chart, process execution chart. That process execution chart is called as a Gantt chart. Okay, so this figure shows, following figure shows the Gantt chart. In this example, every process, all the process P1, P2 and P3 are enter into the CPU. There is no any arrival time mentioned here. If arrival time is not present, then we have to take zero arrival time for each and every process. Means all the processes are enter in the same way, same time in the CPU. So we have to consider to solve the problem, arrival time is 0. It means three processes are enter at the same time. Okay, so by the given sequence, we have to decide which processes enter into the CPU. By this sequence, the first process is P1 process. So see the Gantt chart carefully. P1 process enter into the CPU. That P1 process can execute up to completion of its 24 millisecond time. Means that process can complete the burst time 24 millisecond. Why it is? Because that first come first serve algorithm is a non-preemptive scheduling algorithm. After completion of process P1, that process P1 can release the running state, and process P2 is enter into the running state. P2 process require 3 millisecond. So P2 process starts from 24th millisecond and executed up to completing its job for 3 millisecond. So total time required for execution of P2 is 27 millisecond. At the time 27 millisecond, next process is entered, that is process P3, which also required 3 milliseconds to complete. So process P3 starts from 27th millisecond and ends up to 30 millisecond. Okay, so we have to calculate waiting time, average waiting time for execution of this whole process. For that purpose, we have to calculate waiting time for each and every process. The formula for waiting time is starting time minus its arrival time. Means process starting time minus its arrival time. For process P1, process starting time is 0 millisecond as well as its arrival time is 0 millisecond. So process P1 should have to wait for 0 millisecond. For process P2 starts at 24th millisecond and its arrival time is 0 because arrival time is not given. So 24 minus 0, waiting time for process P2 is 24. For process P3, starting time is 27 and its arrival time is 0. So waiting time for process P3 is 27. Then calculate the average waiting time. Make the summation of waiting time of all the processes and divide by number of processes. We will get the result as 17 milliseconds. So total waiting time of this algorithm, of this example by this algorithm, 17 millisecond. Let's consider same problem in different way. Let's see. If we rearrange the processes, like first process is entered P2, second is P3 and third is P1. So let's see what is the difference between average waiting time of process execution. Your first process is P2, starts with 0 millisecond. It requires 3 milliseconds to complete. So after completing 3 millisecond, process P2 exited from the running state and process P3 enter into the CPU. P3 requires 3 milliseconds to complete. So P3 starts execution from 3 milliseconds to 6 milliseconds, and at 6 millisecond process P1 is entered into the CPU up to completing its own CPU burst time, that is 24 millisecond. So total time required to complete the process of P1 is 30 millisecond, and then calculate its average waiting time. Let's see, if we rearrange the process in the way the process which has less burst time executed first and the process which has largest burst time executed last, the difference between average waiting time in both cases, in previous way, in given previous or actual example, our average waiting time is 17, and by rearranging, it means how we arrange the process by its burst time. Smallest burst time process executed first and largest executed last. Our average waiting time is 3, which is much better than the previous case. It means it increases the performance of the operating system. Okay, but in first come first serve scheduling algorithm, we cannot change our scenario. Whatever the given scenario, we have to accept it and execute the problem, and CPU should have to perform based on the given scenario. For that purpose, we have to use the next algorithm, which is known as a shortage job first algorithm or shortage remaining job first algorithm. In this algorithm, first of all, enter the process which has minimum burst time. Means we have to sort our processes. Whatever the arrival time of the process, we have to sort the process based on its burst time. Sort the process by descending order. Means the job which has less burst time enter first into the CPU. This algorithm is called as a shortage job first algorithm. Let's see one example of it. See carefully. There are 4 number of processes, P1, P2, P3 and P4. Every process has its own arrival time. P1 process has 0 millisecond. P1 process arrival time is 0th millisecond. Burst time, it requires 8 milliseconds to complete. P2 arrival time is 1, burst time is 4. P3 arrival time is 2, burst time is 9. P4 arrival time is 3 and burst time is 5. First of all, we have to construct a Gantt chart for it. Sort the processes based on its burst time, minimum to maximum. First process is enter into the CPU with arrival time 0, because 0th millisecond, whatever the process enter is considered first, because at that time no any process is present for the execution. So first process enter is a P1 process. After 1 millisecond, new process is enter, that is process P2. Is it? In a queue, we have 2 processes, process P1 and process P2. P1 completed its 1 millisecond time, 1 millisecond burst time execution. So P1 required 7 milliseconds to complete the job, and P2 required 4 milliseconds to complete the job. So we have to sort the queue first. The minimum burst time is 4. So first of all, give the priority to execute the process P2. And for that purpose, To implement this algorithm, we have to use the preemptive process execution method. So preempt the process P1 from the running state and enter the process P2 into the running state because P2 has less burst time. Then process P2 enter into the CPU. After 2 milliseconds, new job is entered, that is process P3. P3 required 9 milliseconds to complete. We got 3 processes in a ready queue. Sort these 3 processes in smallest to largest way. Again, the priority goes to the process P2. In this way, we can construct a Gantt chart. Okay, and then calculate average waiting time. All of we know the formula of waiting time. For every process, the formula of waiting time is starting time minus its arrival time. By that, calculate the average waiting time. As compared to the first come first serve algorithm, shortest job remaining first algorithm gives better performance. And main difference between first come first serve algorithm and shortest job first or shortest remaining job first algorithm is FCFS is the non-preemptive algorithm and HJF is the preemptive algorithm. Okay, and by this comparison we say that HJF is better than FCFS, but depends on the operating system. The operating system decides to use which type of scheduling algorithm is. So two scheduling algorithms are remaining, that is priority scheduling algorithm and round robin scheduling algorithm. We will see that algorithm or the process execution of that algorithm in the next lecture. Till then, goodbye and keep watching.